All right, so you said that you would like to see this problem, so here I'm going to do it. I'm not going to do the graphing because once you have the expressions you can make a graph just by plugging in angles. So we have this crane and boom. There's a couple different forces that we have to deal with. So first I'm going to draw these outriggers. I'm just going to call this force A and this is force B. And those are the things that are supporting the truck. This G1 is the weight of the truck and the crane. So I called that just G1 for now. And this represents the weight of the boom. And then I ended up calling this W because that was the weight that it was supporting. For me, it was 1,200 kilograms. I just wanted to talk a little bit about the units here. So they had the truck and the crane, they said, so G1 was 18 megagrams, and then we'd multiply that by 9.81, but this has to be in kilograms. So doing what my unit change is this is 18 times 10 to the 6 grams, and then there's 1,000 grams in a kilogram. So essentially you can see what ends up is the 18 megagrams is the same as 18 times 10 to the 3 kilograms. And so we'll multiply that by 9.81 for the acceleration of gravity. And then the same for G2. G2 is equal to 1,800 kilograms times 9.81. And the weight for me, I don't know if everyone got the same, is 1,200 kilograms, and then we'd multiply it by 9.81. So those are just some of the numbers that we have to deal with. So when I'm looking at this problem, one of the things that I can look at for equilibrium is the forces in the y direction. We don't have any x forces, so that's nice. And positive forces are A and B. And the negative forces are all the weights. So I have 18 times 10 to the third times 9.81. So that's the weight of the truck and the crane. And then the weight of the boom, which is 1,800 times 9.81. And then the weight that we are holding at the end of the crane, which is 1,200 times 9.81. So if we put that all together, that's all equal to 0. A plus B equals 2.06 times 10 to the 5th newtons. That's something that we can use later. So this is an expression that we can come back to. Now, if I want to find these forces A and B, the way to do those is by looking at moments about a point. So I'll go to the next slide. I'm going to redraw A, B, G1, G2, and W. And so the first question wants to find the reaction at A. And if I want to find A, then I'm going to choose B as my pivot point and look at my moments about point B and set them equal to 0. So if I look, I'm going to just go from left to right with my forces. A is a clockwise, going to call it a clockwise rotation about point B, and it is a distance 4 meters away from point B, so that's that moment. G is going to cause a counterclockwise rotation, so that's going to be 18 times 10 to the third times 9.81 times 1 meter. That's the moment due to G1. Then when I get to G2, that's going to cause clockwise rotation, so that's 1800 times 9.81. Now for the distance of that one, if we look, this distance right here would be given by 6 sine theta, but then we'd have to subtract. We want to find the distance from B to G, which would be this minus this distance, which is 2. So it's 6 sine theta minus 2 is the distance from G to B, which is our rotation point. And then finally, we have the weight, which is 1,200 kilograms times 9.81. The distance for that one would be this entire boom, which is 12.25, and then again subtracting the 2 sine of theta minus 2, and all these equal to 0. So basically I end up with 4a is equal to 18,000 times 9.81 times 1 minus 1,800 times 9.81 times 6 times sine of theta minus 2 minus, it's not going to fit, 1,200 times 9.81 times 12.25 sine of theta minus 2. So this is just a lot of keeping track of all my terms. If I divide everything by 4 and add like terms, of course I have to distribute for these terms because I have 2 terms here. What I end up with is A is equal to 5.886 times 10 to the 4 minus 6.25 times 10 to the 4 sine of theta. Now, you might say, well, that wasn't my answer. Why is your answer wrong? Well, if we keep in mind that we have 2 supports at A and B, this is actually the total for both. And so the value for 1, if I call it n sub A, is just A divided by 2. And that's what gives us the correct value, which is 1. Oh, sorry. Well, I don't have it written down, so sorry about that. But I would just divide it by 2, and that is my answer. Now, one of the questions that they ask is what would be the critical angle where tipping starts to occur. And I moved this part up to part C because we can actually use our answer for part A to answer this question. So n sub A was, well, 2 of them, because the 2 doesn't really matter. 5.88 times 10 to the 4th minus 6.25 times 10 to the 4th sine of theta. Now, when it tips, NA is going to be 0. And so we can just set the left-hand side equal to 0, or just say this equals 0. This allows us to find a ratio that is equal to the sine of theta, which would be equal to 5.88 over 6.25. And this ends up giving us a theta of 70.2. So that's how we find that critical angle. So if we put that baby too far down, and you can kind of see how that would happen, as this thing comes down, it's going to be sort of going further out in front of the truck itself, and it's going to cause an instability and cause it to rotate and flip. And that's bad. To find B, we can go back to our expression for, we found a plus b was equal to 2.06 times 10 to the fifth. And these both represent for the two supports. Remember when I just drew my picture in A and B, this represented, the fact that there's a foot on either side of the truck, but I just wrote them and put them together. So we could say that B is going to be equal to 2.06 times 10 to the fifth minus A. And then to find, if we say N sub B, which is for one support, that would just be taking our answer we got for B and dividing it by 2. So that's sort of like plug in what you got from part A. And for B, I ended up at 14750 minus 6.25 times 10 to the 4 sine of theta, and then we divided that by 2. And that's how we got our answer. So hopefully this helps a little bit to see how we do the problem. The dividing by 2 thing is really frustrating because you don't realize it at first, that there'd be one on each side. But I think otherwise it's not too bad once you see the geometry.